Hi everyone, welcome to the new lecture of 5G series. Today we're going to understand a very important concept in 5G, that is BWP, right? So as the name suggests, right, BWP means bandwidth part. So we are dividing the whole bandwidth into certain parts, as the name suggests. So what does it mean here? Uh, first question came like, why do we have even this BWP in 5G, right? So the thing here is, in BWP, let's say this is your frequency domain, and let's say this is your 100 megahertz, right? What I'm doing is I'm trying to divide this in certain portions. Let's say first portion is this, second portion is this. So let's say this is of 40 megahertz and this is your 20 megahertz. So dividing the spectrum or dividing the bandwidth into certain bandwidth parts, this is nothing but your BWP. And you can assign the BWP number IDs to these parts wherever you are cutting down or you are segregating the bandwidth. So let's say this is your BWP 0, this is your BWP 1, and so on. So if we talk about, LT, right? We were having fixed number of bandwidth across the spectrum once the communication was established. So let's say if I talk about your 20 megahertz, right? So 100 RBs were there, right? So let's say if you want to carry some data, or you cannot change that in between of communication, right? But in NR, you can change this BWP during you are communicating the data towards the GNB, right? And towards the downlink in UE. So what I'm suggesting here is so 5G NR radio basically allows your flexible utilization of available spectrum, right? And second term is EUAS. So it just I have created these terms just to remember, this F means flexible, E means efficient. So it means flexible utilization of available spectrum and efficient utilization of available spectrum. So flexible means, let's say you need 20 megahertz from the 100 megahertz. So you can use BWP 1. And if you need 40 megahertz, you can use this BWP 0, right? And you can have, 4 BWPs at max. So 4 you can define in UL and 4 you can define in DL. So like this you can, and this is different from the initial BWP. I'll explain these things later, but just to be aware of what is initial BWP. Initial BWP is the BWP where UE does the RATCH, right? Right, which is necessary for the synchronization of UE with the network. That is known as initial BWP, right? So now coming towards the LTE and the 5G comparison, right? So if you want to understand this thing in very layman language, right? So let's say you have a very big pizza, okay? You and your friends went to some restaurant. Now, what happens? You have a cutter. Let's say pizza is wholesome. It's not been cut yet. Now you have a magic cutter, or let's say you have a simple cutter. So you divide the pizza into equal slices beforehand. And each of the friends, let's say 6 friends are there getting one slice of the pizza. Now the problem is there. Let's say some of your friends might be super hungry and wanted more pizza. And some of your friends are like not having that much of hunger, so they might not require the full slice. But in LTE, you cannot do that. But in 5G, you can do that on the dynamic basis. Like some friends are, feeling more hungry, so you can give them a bigger slice. And some friends who are having less appetite, you can give them the less or smaller slice of pizza. So here, the big pizza represents the internet, and your friends represents the device, like your phones or tablets. Okay. So you have this magic cutter in the 5G, which can give you the pizza slice as per your hunger or appetite. Similarly, in 5G, this BWP is the concept is similar to magic cutter, which allows the network to be smart and flexible, right? So let me scroll it down. So this BWP allows network to be smart and flexible. See, this was not there in LT, right? So if you see this diagram, right? So in this diagram, what it depicts basically, if you see the very first one here, right? Let me have something to denote. No worries. Okay, let's focus on the A diagram. Okay. So this is your overall career. So even though it is on x-axis, but you understand this is frequency. Okay. In the wholesome frequency, we have this small amount of BWP1, right? Only one segregation is there. Coming towards the B, we have overall carrier and we have two BWPs. BWP1 is same as the previous diagram A, and we have much bigger BWP2 that also contains the BWP1, right? Now come to the C diagram in which we are having BWP1 and BWP2. So these are non-contiguous, right? So these are non-contiguous in the frequency domain, if you see. And D point is where you have BWP1, BWP2, right? And this is some other possible setup. So you can have other BWPs also here, right? As I told you, four BWPs you can have in UL and DL. So accordingly, you can segregate. And these BWPs are different or apart from the initial BWP, which is used for the initial synchronization purpose. So I hope this pizza concept would be relatable to your BWP. Now coming towards the technical part. Now, if you see this LT, right? So uh, this you are using the full bandwidth once your communication is established. So don't you think this is not very efficient? Because sometimes internet can be wasted and not enough for certain tasks, right? But with the BWP bandwidth parts in 5G, we can avoid this problem, right? What we can do, let's say you are using DLUL throughput, or you are watching some 4K videos, 4K example Netflix, you can say. Netflix you are using. So you need more and more data, right? So this BWP is nothing but your more number of RBs. Higher means higher the bandwidth, more the number of RBs, right? So and 5G NR, what is the maximum bandwidth? Okay, I'll leave up to you to answer it the comment section. So what is the maximum bandwidth of 5G, right? So we were talking about if we are using Netflix 4K video, you need more and more data, and you can have the bigger slice or bigger bandwidth part size, right? But if you are using some normal text or some WhatsApp chat, right? So you don't need that much amount of bandwidth. So you can shift to a lower bandwidth part, right? Which is having less bandwidth, let's say not 20 or maybe some 10 megahertz, something like that. As per the configurations, you understand, right? So this is how this flexibility is given to us in the 5G via BWP. So what is the benefit of that? Customizing the internet service sites for the each device. So what will happen? It will work faster and more efficiently. So we are efficiently using our uh, spectrum basically, right? So if I summarize this that example of pizza and internet together with BWP. So why five? So this 5G with BWP is like a magic pizza party where everyone is getting the right amount of pizza slice they want, right? To summarize, BWP in 5G NR is a smarter way to share the internet among the devices, right? And it can adjust the bandwidth size of the internet slice on the fly. On the fly means dynamically, right? Okay. So important thing is dynamically. You can dynamically allocate resources. See, resources are here nothing but of your number of RBs. A number of RBs means BWP, right? So you can say this is an improvement over LT, right? So हमारा LTE से 5G में there was an improvement, right? Which is BWP. Okay. In LT we were having fixed bandwidth, right? Which can lead to inefficiency and wasted resources. Okay, so this should be why this error is coming. Inefficiency and wastage of resources, right? तो फिक्स बैंडविड्थ है तो हम उसको एफिशिएंटली वी कैन नॉट यूज दैट एफिशिएंटली, राइट? और रिसोर्सेज को क्या होगा? वेस्टेज होगा इवन फॉर as I explained you earlier, right? So now you understand one thing here. Uh, this is improvement, and now BWP in 5G is more flexible, efficient, and faster. So if we talk about 5G, so this is more efficient and flexible and faster, right? So these two things, if anyone asks in the interview, you can tell them how these things are different basically in LTE and 5G as per the BWP. Okay. So going forward, I'll go to the technical part, which is more important here. So you just try to listen here, whatever I am saying, right? I'll speak slowly just to be aware of. So BWP part plays a crucial role in 5G NR, right? That allows flexible utilization of available spectrum. So we are now discussing the technical aspect of DW. So very first point I told you is flexible utilization of available spectrum. See, I am repeating it so that it will fit in your mind. Flexible utilization available resources. Okay. So it's all about efficient resource management also, right? In 5G, available spectrum is divided into multiple bandwidth parts, and each part can be independently allocated to different users or devices based on their specific needs, right? So let's say this is UE1, this is UE2, this is UE3. So UE1, let's say this is using WhatsApp, and UE2 is using your Netflix. UE3 is on your, like, say, VoIP call, right? So let's say you have this complete bandwidth and you have 4 BWPs, right? So I'll just name this. So this is your BWP0. This is your BWP1. This is to see, this is just for example, you understand the thing, how it is happening. So let's say this is your 10, this is your 30, this is 20, and this is 40. See, it is not necessary to cover the whole bandwidth. You can just divide it randomly. I mean, it's configurable basically on the network side, right? So the one user UE1 is using WhatsApp, right? So it's WhatsApp means it's only using chat, just to be specific. So you can allocate him the 10 megahertz bandwidth, right? So it means you can allocate him BWP3, right? Now, if I talk about your Netflix user, it requires more bandwidth. So you need to assign it to BWP0, which is having 40 megahertz. Or you can have bigger bandwidth also, could be going to 100 megahertz, right? Depending on the 5G uh, maximum, bandwidth capacity, which is possible. And UE3 VoIP call, let's say you can assign it to BWP1, right? So this is how you can allocate resources, BWPs to devices, UE person, or with the examples, a pizza slice you can relate it to basically. So this should be very simple for you now to understand how this BWP is working. Okay. So to understand BWP, so we compare this LT technology, right? In LT technology, available spectrum was typically divided into fixed size bands, and these bands are assigned to user in static manner, right? So LT में हमने क्या किया था, स्टैटिक मैनर में बैंड को अलोकेट किया था, बैंड, or you can say resource allocation, right? Each user is allocated a fixed bandwidth. Each user is allocated a fixed bandwidth, right? Now, that bandwidth remains unchanged during the communication session, and this remain unchanged during the communication. So once the UE is connected, you are doing some data transfer or uploading, downloading, whatever it could be there, right? So this fixed bandwidth would be unchanged, right? Uh, Now the thing comes, each user is allocated fixed bandwidth, and that bandwidth remains unchanged during the communication session. This fixed allocation can sometimes lead to inefficient use of spectrum, right? Especially when the user's data demand vary over time. So when the data demand vary or change, so डेटा डिमांड अगर टाइम के साथ चेंज होगा, तो उस केस में ये हमारा जो फिक्स बैंडविड्थ का जो कॉन्सेप्ट है एलटी में, ये क्या हो जाएगा, इनएफिशिएंट हो जाएगा. See, something might be repetitive, but you try to understand. This will just, solidify the concept of BWP, right, in your mind. Okay. So especially when, okay, data demands vary over time. On the other hand, BWP in 5G allows more dynamic and adaptable approach, right? So if we talk about, we change the color, which color we have not used, yellow, okay. So अगर हम 5G का बात करते हैं तो 5G में क्या होता है, we have this more dynamic and adaptable approach, right? I'll write it here. Dynamic and adaptable approach, right? सो डायनेमिक एंड अडेप्टेबल अप्रोच का मतलब क्या है यहाँ पे स्पेक्ट्रम यूटिलाइजेशन के लिए, कि अवेलेबल स्पेक्ट्रम कैन बी डिवाइडेड इनटू स्मॉलर पार्ट्स एंड ईच बीडब्ल्यूपी कैन बी एडजस्टेड इन साइज डिपेंडिंग ऑन द यूजर्स नीड्स एंड द नेटवर्क्स रिक्वायरमेंट, राइट, एज आई टोल्ड यू, 20, 10, 30, 40, 100 मेगाहर्ट्ज. डायनेमिक एलोकेशन इनेबल्स मोर एफिशिएंट यूटिलाइजेशन ऑफ स्पेक्ट्रम. तो डायनेमिक से क्या होगा, मोर एफिशिएंट यूटिलाइजेशन होगा. Utilization of spectrum. So making it easier to meet the varying data demands in different situations, right? So just think of BWP as a tool that allows 5G to be like a flexible rubber band. So it can stretch or contract as needed, right? So provided just the right amount of bandwidth to each user rather than a fixed rigid allocation that was having an LT, right? सो अब इस फ्लेक्सिबिलिटी का हमारे को फायदा क्या है, लाइक व्हाट व्हाट वी आर डूइंग और व्हाट वुड बी हैपनिंग. सो दिस फ्लेक्सिबिलिटी अलाउज द 5G टू रिस्पॉन्ड क्विकली टू द चेंजिंग नेटवर्क कंडीशंस, राइट. इससे क्या होगा, पहली बात तो ये है कि हम फर्स्ट थिंग इज दिस चेंजिंग नेटवर्क कंडीशंस. So we can respond quickly to changing network conditions and user demands. See, Abhi, this part is theoretically going on. So I'll explain this thing later on, right? First thing is changing network conditions. Second thing is user demands. So, sorry, I got disturbed with the message. Yeah, so okay. So user demand. Third thing is optimizing resource utilization and overall network performance, right? So इससे होगा क्या, हमारा जो resource utilization है वो क्या होगा, optimum होगा. Optimizing the resource allocation and overall network performance, right? अभी देखो यहाँ पे मैंने यहाँ पे आई हैव रिटन टू थिंग्स, चेंजिंग नेटवर्क कंडीशंस एंड यूजर डिमांड, right? So now you can ask what are some changing network conditions, what are user demands, what is optimizing resource utilization, what is overall network performance, right? These 4 points I have written here, right? Let me highlight it. So this is first, this is second, this is third, and this is fourth. Okay. First, second, third, fourth. Okay, so let's talk about the very first point, right? So first point says changing network conditions. So changing network conditions में how would we respond? Changing network conditions. So changing network conditions means the condition of a 5G network channel can vary over time. Example के लिए what we can take is certain time of day there might be more people using the network. So if you see in the daytime everyone is awake, so they would be using the data traffic, right? Morning, night, you are on Instagram, you are scrolling the reels, so you are using more and more data, isn't it? While at the, let's say at the night time, you might not be using the, more data if we don't consider the sleepy owl people. So this is situation is higher data in the daytime, lower data traffic in the night time. So BWP allows the network to adapt to these changing situations and adjust how it can allocate the data in daytime and in nighttime as per the requirement, right? This is the changing network condition in the day and night time. Second thing is user demand. See, all these points are interconnected only. We just trying to understand on every aspect. So this is your user demand. Now, if you talk about user demand, so different users have different data requirement, right? Some might be again watching high definition videos, while other might be using simple text messaging. So this demand can vary widely, and BWP in 5G again will be allocating the more bandwidth to user with high data demands and less bandwidth to with lower data demand. So I can write it down here. More bandwidth to higher data demands and bandwidth to lower data demands. Okay. Now, third thing is optimizing resource utilization. Let's move forward to the third point. Optimizing resource utilization. So what happens in this? This means making the best use of available resources such that the spectrum or internet in 5G network can be used efficiently, right? So BWP helps in efficient resource management. कैसे? By dividing the available spectrum into smaller parts and allocating them as per the user needs. So इसमें आप simply लिख सकते हो allocating the bandwidth as per user needs. Fourth point is your overall network performance. एक कलरफुल पेन आ गया है. Overall network performance. So overall network performance means this refers to 5G network works as a whole, right? Dynamically adjusting bandwidth with BWP, the network can ensure that each user's demands are met efficiently. So when network perform well, user experience fast data rates, better connectivity. So we'll say if the network perform well, network perform अच्छा करेगा, then we'll be having faster data speeds. Faster data speed, right? And better connectivity, right? So, and fewer delays is network transmission, right? So, changing network conditions and users' demands, optimizing resource utilization and overall network performance means BWP in 5G, the network to be more flexible and adaptable. It can adjust the way it shares the internet among the user based on real-time changes in network usage and user needs. So, घूम फिर के we are telling the same thing, but you need to understand how it is going and what are different aspects of it. If someone asks, you can tell all the different points which are there. Okay. So let's move forward. So guys, we have seen previously, right? So the theoretical part of BWP. So now I'm going to show you some, some configuration and how many BWPs we have, the types of BWPs, and how this configuration looks like. So let's focus on this very first diagram, right? Okay. So this very first diagram, this says, so on the y-axis we have frequency, and x-axis this is your time basically. So this is showing the figure showing bandwidth part types. Okay. So the very first you see this SSB is there, then your initial BWP is there. So I told you already, right? Initial BWP is for your RAG and synchronization purpose, uplink synchronization. Then you have first active BWP. Okay. And this is another BWP where, so always consider BWP in frequency domain, right? Because it is defined in the number of RBs. The bandwidth is in frequency. So this first active BWP is there. So ID is not given, like BWP ID 0, 1, 2, 3 is not given here. Simply just understand. So this is first active BWP. Now U is switching to another BWP. This is another BWP. And this is different BWP, right? So this is how BWP switch is happening. And I told you earlier, in apart from initial BWP, there are four more BWPs. That is four in DL and four in UL. So if we start counting, I'm sorry. So this should be, so it will start from BWP ID 0, BWP ID 1, BWP ID 2, BWP ID 3, BWP ID 4. So this is your initial BWP, right? This one is your initial BWP, and rest are your BWPs. So you can say it could be, each one can have DL, UL, right? UL and DL, UL and DL, right? Now you understand one thing. There are different BWPs, but at a time only one BWP would be active BWP. Okay, and after you will be switching to different BWP, that BWP becomes active, right? So if we see this second diagram, so if you see this second diagram, right, just focus on the uh, frequency side allocation, right? So we have BWP 1, 2, 3, and then 2 again, 1 again. So you see the frequency, BWP 1 is having higher bandwidth, right? BWP 2 is having lower bandwidth. Then 3 is having somewhat higher than BWP 2 but lesser than BWP 1. Again, you have BWP 2. Do not focus on time axis, just focus on frequency axis. And then this BWP 1, right? So this is the configuration example they have given. So BWP 1 is configured via bandwidth 40 megahertz and subcarrier spacing is 15 kilohertz. Bandwidth 2 is bandwidth BWP2 is 10 megahertz and subcarrier spacing is 13 kilohertz. So you understand, right? Here we are having different subcarrier spacing. So here number of slots are getting changed, if you understand, right? For 15 kilohertz, one subframe would be having one slot. For 30 kilohertz, one subframe would be having two slots. BWP3 is 20 megahertz and SCS is 60 kilohertz, right? Now you understand for which uh, frequency range this 60 kilohertz subcarrier spacing we use. This is our FR2, right? So this belongs to FR2. So according to the need of the UE, it can be assigned a different BWP from the network, or it can be switched to the different BWP as per the data requirement, right? That we have already discussed. So this would be considered as a part one of BWP. There is lot there in the BWP, and this BWP is also related to the core set, control resource set in 5G. So I'll be covering that part in next video. So till now, just focus on these things, and please let me know in the comment section if you like the video, if you dislike the video, what you like, what you didn't like, if there is any improvement needed in the video, or any topic you want me to include for the next sessions. Okay, chalo, I'll see you in the next sessions. Okay, bye.